Elementary Algebra, Final Assessment 2, Review, Questions 1 through 3. In Question 1, the instructions read solve. Question 1 reads a minus 1 equals a negative 4. For this problem, we're going to use the addition principle of equality. To use the addition principle of equality to eliminate a term from one side of an equation, add the additive inverse of that term to both sides of the equation. When we look here, on the left side we have a minus 1. To isolate the a, or the variable, on its own, we're going to sum to both sides a positive 1. This leaves us on the left side with a plus 0 equals negative 3. To clean this up, it reads a equals negative 3. If we wanted to check our work, we would take the negative 3 and plug it back in where we see a. So as a check, we could take the original problem, a minus 1 equals negative 4, plug a negative 3 into the a position, and solve. Negative 3 minus 1 is the same as saying negative 3 plus negative 1. Negative 3 plus negative 1 makes a negative 4, and this equals negative 4. This is a true statement, so we have solved correctly for a. Let's follow the same procedure we used for question number 1 to solve question number 2. When we look at this one, we can see that we're going to need to solve or add the term with the variables to both sides, as well as the constants to both sides. Here we actually have 4 choices. It doesn't matter. I can add a negative 3 to both sides. I could sum a negative 13 to both sides. I could sum a negative 4p to both sides, or I could sum a negative 11 to both sides. The only suggestion we have here is to look at the variables first and decide which one you would want to add to avoid creating a negative. In this case, we want to add the negative 3p to both sides. This will clear the 3p from the left side, and on the right side leave a positive p-value. So this comes down to 0. Then I have positive 13 equals a 1p plus 11. Another way to write that is 13 equals p plus 11. There's always a 1 in front of our variables if we don't see anything, so we don't have to show it. Next, I'm going to isolate the p by summing a negative 11 to both sides of the equation. This leaves me with a positive 2 on the left and p on the right. So I now know that p is equal to 2. I can go back and check this by plugging the 2 into the p position on the original problem. If I come out with an equal value to both sides of the equal sign, then I've solved correctly. In question number 3, we have a little bit more going on. This time we're going to simplify before isolating the variable. We see here that we have parentheses present. We will clear the parentheses first to simplify. Second, we will combine like terms to simplify. So starting on the left side, I see I have a 2 waiting to be distributed through. But because there is a minus sign in front of the 2, before I distribute this, I want to rewrite the equation so that the negative goes with the 2. I do this by writing it as 7y, rewriting the minus sign as a plus, and now the term that follows, the constant 2, gets a negative. And copy down the rest of the problem. On the other side, I'm going to do the same thing. As long as I'm doing a rewrite, I have that minus sign there. I'm going to turn that to a plus. That means that negative goes on to what follows it. You can think of this as being a negative 1, or you can think of it as just a negative being transferred to everything within the parentheses that follows. Okay, so now I'm ready to distribute, to clear the parentheses. The 7y stays the same. The negative 2 distributes to the y, so it's a negative 2 times y to make a negative 2y. Then a negative 2 distributes to the negative 3. This creates a positive 6. On the other side, 8y plus, I have a negative 1 to a positive 4y, so this makes a negative 4y. Then a negative 1 to a positive 12 creates a negative 12. I can put parentheses around these negatives just so that it makes it a little bit easier to see them. I can see that the negatives are held to those terms. Next, to simplify, I want to go through and combine any like terms. Let's start on the left side. On the left side, my like terms are the 7y and the negative 2y. So I'm going to combine these two. They're opposite, so I'm going to subtract. So 7 minus 2 gives me a positive 5y. The 6, there's nothing to add to it, so I just carry it down. Let's look at the right side. Now I have the 8y to the negative 4y. So 8 minus 4 leaves me with 4y, and then the minus 12 just carries down, or negative 12. Alright, so now I'm ready to use the addition principle. Again, I'm going to look at the variables first. I have a 5y and a 4y here. If I move the 4y to the other side, I avoid creating a negative. It may help me to evade one extra step at the end if I try to get rid of that or avoid the negative at first. So minus 4y minus 4y. This leaves me with a 1y. I don't need to show the 1, however. I can just show the y. Plus 6. This one went down to 0, plus a negative 12. Next, I want to move those constants. I want that y on its own. So I'm going to come in here and I'm going to subtract a 6 off both sides, minus 6. So now I'm left with y plus 0 equals, this position was 0 as well, plus a negative 18. So just to kind of clean it up here, I don't need to show those zeros, so I know that y is equal to negative 18. Again, as a check, I could take that negative 18 and plug it back into the y position on the original problem and solve it as a check.